Good morning, students. Yesterday we have seen about the group 6 elements of p block element. P block means the elements in their outermost shell, the electron is entered in a p block. That's what that elements are to be named as a p block element. P block elements are having, or p orbital, which is of having three types: px, py, pz. Each one carries the two electrons, and that's what the capacity to contain the electron, it is the 6 electrons. Today we will see about the nitrogen, the group 5. Group 5, it means that we are knowing easily that the elements of group 5, they are having that NH2 NP3 electronic configuration. So at the center of the periodic table, all these group 5 elements are there. Top of the group, the non-metal, nitrogen and the phosphorus is there, and bottom of the group there is the metallite, which is metallic elements with non-metal characters, that is antimony and the bismuth. So the nitrogen, whose atomic number is 7 and the electronic outermost configuration is 2s2 2p3. Phosphorus, atomic number is 15. Outermost electronic configuration is 3s2 3p3. Arsenic, atomic number is 33. Outermost electronic configuration is 3d10, 4s2 4p3. Antimony, atomic number is 51. Outermost electronic configuration is 4d10, 5s2 5p3. And the bismuth, atomic number is 83. Its electronic configuration is 4s14, 5d10, 6s2 and 6p3. So as you have seen on the slide, you are knowing about the NH2NP3 is the general electronic configuration of group 5. So total of 5 electrons are there in the outermost shell. So that plus 5 is the oxidation state they may carry, or sometimes that plus 3 or that minus 3 oxidation state they may be stabilized. Group 5 elements can form 3 covalent bonds. First is sharing the 3 unpaired electrons which are present in the p orbital, that is the outermost, and that's what gives compounds with the oxidation state plus 3 or the minus 3. Plus 3 oxidation state, when they carries, that time they are to be donating that p orbital 3 electrons to the outermost for the bonding, and minus 3, it means that they are accepting the 3 electrons from the outermost for the bonding. Each atom has a lone pair of electrons, which enables atom to form dative covalent bonds. When they do this, group 5 elements can form some compounds with oxidation state plus 5 also for the group 5 elements. And this is a very special case which is we can easily understand. The first of element is the nitrogen, and we are seeing about the characteristic of the nitrogen, how it is to be important in the group 5 element. This is the first of element in the group 5, very abundant element in the nature, very unreactive, N2 unreactive because of strong triple bond which is of having that nitrogen, always showing, we are showing that 3 bonds holding nitrogen together. Bond enthalpy of nitrogen is plus 945 kilojoule mole minus 1, and the bond enthalpy which is of plus 158 kilojoule minus 1. Hence, most reaction of nitrogen having high enthalpy, which requires the temperature and the catalyst to make them occur. Haber process, high temperature plus ion catalyst, that is the lightning of the 2000 degrees centigrade to make nitrogen react with the oxygen. So that's what, while lightning is there, there is that nitrogen oxide which is to be formed. Now another example of nitrogen which is in the form of the compound, that is ammonia. Ammonia is nitrogen hydride, that is NH3, which is having that lone pair of electron and which is not involved in the bonding. So the dative covalent bonds which is possible here. In ammonia, which is a base, it forms the dative covalent bonds to hydrogen ions to give ammonium ion, that is NH4 plus. Remember, once dative covalent bonds formed no different from covalent bonds. NH3 also forms dative covalent bonds with the Tm ions, the terminal ions, and is a good ligand in the complex. So which is of showing on the diagram on the slide of previous. See, let us see one by one the nitrogen oxides. First oxide, it is nitrogen monoxide, NO. It is a colorless gas, turns to the brown in air, and it combustion processes thunderstorms formed in the soil by denitrifying bacteria. Another, it is the nitrogen dioxide NO2, which is a brown gas and it is a toxic in nature. From oxidation of NO in the atmosphere, there is the formation of NO2. Third is the dinitrogen oxide, that is N2O, which is again a colorless gas and form the soil by denitrifying bacteria. Nitrates, two kinds of nitrates ions involved in the nitrogen cycle. One is the nitrate plus 3 oxidation state, that is NO2 minus, and another it is the nitrate oxidation state is 5 NO3 minus, and both are called nitrates but distinguished by showing oxidation state 3 and oxidation state 5 of nitrogen. See the bonding which is showing on the slide of nitrate oxidation state 3, that the charge is delocalized over the two nitrogen oxygen bonds which are equivalent. So the nitrogen is middle, which is of having lone pair electrons, and by the double bond oxygen and oxygen which is terminally formed. Another nitrogen 5, as you have seen on the slide, by using its lone pair to a dative covalent bond to an oxygen atom, the nitrogen increases its oxidation state to +5 also. Nitrate 5 ion NO3 minus. It is oxidizing agent metal nitrate. Compounds are very soluble in water. And nitrate plus 3 ion, which is nitrite, it is to be showing NO2 minus. It can be reducing or oxidizing agent metal nitrate compounds which are soluble in water. So dear students, you have to practice with the drawing the structures of nitrate, nitrite. You have to remember the electronic configuration of the fifth group element and the characteristic and the physical properties as usual. So write the fill in the blanks which are given in the text, read it carefully, solve it, and mail me drsmitagiri2012@gmail.com. Thank you, take care, be safe, increase your skills as much as possible, help your parents. Thank you.